Yes. Again, welcome to Stress Style, right? There is a strength of materials we'll be discussing today. In the earlier sessions, we have been, came across the various elastic constants. In this things, we come across the contents. Again, we discuss on the same chapter, that is a simple stress and strain. In these sessions, we'll be going to discuss what is the stress strain curve. Yes, very important. See, any material, whether it may be a steel, whether it may be a ductile material, malleable material, or brittle material, it should be subjected to a testing. Why this testing is required? This testing is required because to get the entire properties, that is, which includes the ultimate stress, yield stress, elasticity region, plasticity region, what is the ultimate load which acts, what is the proportional load it takes, what is the factor of safety, what is the working stress is required, what is the same. The final thing is, for conducting this test, it is used to find what are the types of strengths is there in the material to resist the actions. To resist those actions, these types of forces are very essentials. Right? Today we will be going to discuss what is the stress and strain curve for the ductile material. Stress and strain curve for the ductile material. Yes, you can see the figure. Origin, it has been drawn in the horizontal stress. It is been defined in the Newton per millimeter square, and strain, and there is a graph has been plotted. You can see the graph A to B, B to C, C to D, A to F, and in the right side there is a specimen where is the axial load of a ductile material will be subjected to the tensile test, right? Those tensile tests, there is an extensometer where this extensometer will define the change in length where it occurs, right? First we go for what is the steps which has been included. The stress and strain curve, it is a graph which has been plotted with the stress on the y axis and the strain x axis as shown in the figure. From the values obtained by conducting this type of test, a specimen has been shown in the figure. The test is conducted by gradually applying the increasing pulling force on the standard test specimen until the specimen break. Yes, then in which machine this type of testing will be conducted. This type of material will be subjected to the universal testing machine. How? By conducting the tensile test. The tensile test is conducted by fixing the test specimens at both the ends in the universal testing figure. The figure has been not shown in the figure. Okay, what happens at this stage? Both the ends of the specimen will be loaded. The initial conditions. Whenever there is no force, it is represented by the origin O on the strength. Whenever there is no force, it is origin. It is been represented by the origin O in the stresses, right? And the strain diagram. As the force is gradually increased, the specimen also begins to change in length gradually. According to this, stress will be proportional to the point P. Yes, as the load being increased, what happens? There is a gradually increasing change in length up to a limit called as a P. That is the proportional limit called P is the here we have been given as a P. That is the proportional limit. During this period, the material perfectly obeys the Hooke's law. That is, within the elastic limit, the stress is directly proportional to strain. On further increase in the force, on further increasing in the force up to the on the further increasing the force up to the point B, what happens? It disappears. Although the elongations, it disappears completely on removal of the pulling force. But between the points A and E, the material does not obey the Hooke's law. Still, till this point, still this point B, the material will be elastic in nature. This point is called as the elastic point. It has been explained in the earlier sessions. Once the material is within the limit elastic, it can be regains its original shape and sizes. Right? Next, further increasing in the beyond the elastic limit, that is point B, the plastic deformation stage takes place. The strain begins to increase more rapidly than the corresponding stress till the point D. Without much increase in the force, the point D is called as the yield point. That is, we have the 2 points, that is the upper yield point and the lower yield point. What happens in these conditions? The material will be still in the plastic state, and this phenomenon of slow elongations is called as the creep. Right? And the cross-sectional area of the test specimen decreases, whereas the length increases. Again, now what we do is, again we increase in the force after the creep. A maximum value of the pulling force is reached at the point E. This point is called as the ultimate point. The point which stretches locally over a small length forming a neck. It forms the neck. This maximum stress is called as the ultimate stress. As soon as the stress has been increased, it will be found that the cross-sectional area of the specimen of the neck reduces more rapidly, and finally rupture takes place at the point F. That point is F is called as the breaking point. Corresponding the stress at the point is called as the breaking point. Yes, this is the stress strain relationship. Once what happens? Slowly, gradually, the load will be applied. It will be leaped to the proportional limit. Once it crosses the proportional limit, it crosses the elastic limit, so that the material can regain its shape after the removal of load. Once it extends the limits, it attains the yield point. At this point, the creep will occur. What happens? The length increases, but the area decreases. That is called as a creep. And once this reaches the creep point and the ultimate, therefore, the ultimate stress will be divided, which causes the neck and a cup shape. Once it causes the ultimate stress, the breaking load will be applied gradually, so that it will be formed on the cup and cone. Well, see, this type of the stress strain relationship is of the ductile material finally will be come in the crossing the conducting the tensile stress before the ductile fracture. How it will be there like this? What is the grip, what is the tapering length and the gauge length? That there is a change in length, there is an increase in length, whereas the decrease in area. You can observe of the ductile fracture, the same thing will be occur, whereas in the brittle fracture the cup and cone will be differed. So this is the various purposes for conducting the tests on the conducting on the ductile material. Right? What happens in the brittle material? There is no, in the brittle material, there is no appreciable change in rate of strain, there is no yield point and no necking takes place. The ultimate point and the breaking point are one and same. The strain of the failure is very small. Yes, there is no yield point, no necking takes place. So only there is cup and cone. No cup and cone has been formed. Therefore, it is the difference of the conducting the ductile as well as the brittle fracture. Okay, this in this slide we came across what are the steps to be followed for the conducting the tensile test on the ductile material as well as the brittle material. Now we go for the multiple choice question. Number 1. The slope of the stress strain curve in the elastic deformation region is number A, elastic modulus, number B, plastic modulus, number C, Poisson's ratio, number D, none of the mentioned. Answer is A, elastic modulus. We'll check the answer. Yes, answer is A. Number 2. What is the stress strain curve? Option A, it is the percentage of stress and strain. Option B, it is the relationship between stress and strain. Option C, it is the difference between stress and strain. Option D, none of the mention. Answer is option B, it is the relation between stress and the strain. Number 3. Which point on the stress strain curve occurs after the proportional limit? Right, you can see in the slide which point on the stress strain curve occurs after the proportional limit. We'll get the answer is, we'll check it. See, after this is A is the proportional limit, we getting the B is the elastic limit. Well, see the in the options, yes, there is the option C is the elastic limit. We check the answer. Yes, the correct answer is C. Number 4. Which point on the stress strain curve occurs after the lower yield point? Yield plate, upper yield point, ultimate point, none of the mentioned. Which point on the stress strain curve after this one? That is called as the ultimate point. It is called as the yield point. So the answer is C. Ultimate point is the correct answer. Which point on the stress strain cover after yield point? Yield point, lower yield point, upper yield point, ultimate point. The answer is we go for the ultimate point. Number 6. Which point on the stress strain curve occurs after the ultimate point? Last point, breaking point, elastic limit, material limit. We come across the slide. There is the ultimate point. E is the ultimate point and F is the breaking point. We come finally, the answer is F, that is the B, breaking point. This is 2, 3, 4, 5, 6. Thank you.